Hello viewers, today we would be starting with chapter Radioactivity of class 10. So first of all we should know the basics. First is what is nucleus. So we have already studied that nucleus is the combination of proton and neutron, and we know electrons revolve around the nucleus. Now why we are dealing with nucleus here? Because radioactivity phenomena is actually concerned with the nucleus. So that is why before we start with anything about this chapter, we should be clear that what is meaning of nucleus. And we know nucleus is positively charged, electrons are revolving around it, and they are negatively charged. So some terms that you have already studied in the previous class for I think in chemistry, that is proton and neutron together are called nucleons, and they are mass number, which is denoted by symbol A. Atomic number is given by either number of electrons or number of protons, but this condition is only valid when the atom is neutral. Otherwise, if atom is not neutral, so number of electron and protons will not be same. But remember, proton number is always given by atomic number, whether it is charged or not, and the symbol given for this is Z. Now how we would represent the element which has got mass number say A and atomic number Z? So representation of this is given by X as an element. A would be written on the top and Z would be written at the bottom. For example, if suppose you have sodium atomic number is 11 written at the bottom, and 23 is the mass number which is written on the top. So this is the representation. Now how to find number of neutrons? It's not proton, this is neutron. Neutrons are done by subtracting A and Z. That is, if from proton and neutron number I subtract proton number which is given by atomic number, so I will definitely get my number of neutrons. So the way to find out this is you will subtract atomic and mass number. For example, if suppose in this particular element you want to find the electron, proton and neutron, so as I said electron, because this atom is neutral, electron and proton number would be equal here, which is given by atomic number 11, and number of neutron is denoted by A minus Z, that is 23 minus 11, that is equal to 12. Okay, now few more terms that you have to remember in this chapter is what are isotope, isobars and isotones. So isotopes are the elements which have same atomic number and different mass number. Because I'm saying the atomic number is same, so I can easily say that these isotopes would be of the same element, because their atomic number is same but mass numbers are different. So one of the examples is chlorine. Second is hydrogen. Hydrogen exists in 3 isotopes, that is protium, deuterium and tritium, and you can see atomic number for all hydrogens are same and the mass numbers would be different. Next is isobars. Isobars on the other hand would be the one which have got same mass number but different atomic number. Now I'm saying different atomic number, it means that I'm talking about 2 different elements. So here I have taken one example, say element X dash, and you can see this is same and these are different. And this one more term we have in our Selena's book, that is what are mirror isobars. So mirror isobars are when the proton and neutron number they get interchanged. You will understand this with the help of an example. For example, if I want to write here, I'm not going to write the electron, but we know here the number of electron is 11, here it is 12. I'm going to write about proton. Proton is 11, here proton is 12. Now neutron, here you will do 23 minus 11, that is equal to 12, and here if you do neutron, 23 minus 12 equal to 11. So you can see these are just the opposite of each other, just like mirror image where the left appears to be right. So here the proton number for this particular element appears to be the neutron number for this particular element inside the nucleus, and here same proton number is just same as number of neutron for this particular element. So sodium this and magnesium this, they are said to be mirror isobars. And why isobars? Because you can see their atomic numbers are different, mass numbers are same. Now next we have here the next topic is isotones. Isotones are the one which has got same number of neutron, means after subtracting you should get same neutron. Let me take an example of element, say X 24, 12, and say why we have 11, 23. So if you subtract to find their number of neutrons, so that would be 24 minus 12, 12 here also 23 minus 11, 12. So number of neutrons are same, so x and y, they are isotones. Now the main part of the chapter, that is radioactivity. This whatever we have done is the introduction part, which is important. You might get 1 or 2 marks question in your board exam regarding the previous topics that have been covered, but the main part of the chapter is this. From here definitely one question would be coming for sure. Okay, now when I say radioactivity, I told you in the beginning that we are going to deal with here nucleus, and radioactivity is a phenomena of the nucleus, where the nucleus being unstable means it is going to emit certain harmful radiation into the environment. So that is spontaneous means something which happen on its own and suddenly. It is going to emit spontaneous emission of radiations are something which is invisible to us and we cannot see them, right? And these radiations are definitely very, very harmful for us. Now because it is a nucleus phenomena, so we would be dealing with two things here, neutron and proton. For condition for radioactivity, this question has been asked previously in the board exam also, that the condition is that number of neutrons should be greater than that of proton. This is the condition for radioactivity, very, very important. Next is radioactivity, because it is a nuclear phenomena. Nuclear phenomena means where nucleus is involved. So it will not depend on any kind of physical or chemical change or change in temperature. See, they might give you a question like, suppose they give you that you have a uranium 235, right? You were doing some reaction and then after that this uranium 35 was kept at a temperature say from 20 degree to say 40 degrees Celsius, right? So what will happen to the nature of the radiation, or will the radiations emitted will be more? So your answer would be no, because nucleus is not affected by temperature or anything. It is only the electrons which are affected, right? That too which are revolving around the nucleus. So you will say nothing will happen to the nature of the radiation. It will remain same whether you change the temperature, whether you freeze the uranium, or you heat it, or you put it in electric field, magnetic field, I mean whatever you do, it is not going to affect your radiations, right? Now because we are dealing with radiations, and I told you it is a random phenomena, you never know when the nucleus is going to disintegrate. It is going to break down. When it is going to break down, it is going to emit the emissions, spontaneous emissions. And the radiations are of three types here, that is alpha, beta and gamma, where alpha is actually doubly ionized helium. Doubly ionized helium means, you can see on helium we have got this +2 charge, that is why it is doubly ionized. Beta is the electron, but how this electron is different from the other electron which is revolving around the nucleus? Remember, this electron has been generated by nucleus. Sounds weird, but yes, this electron comes from the nucleus, right? And this further detailing we are going to do as the chapter proceeds. And gamma is the neutral radiation, right? Okay, some sequence you have to remember because they do ask you in the exam for sure. Okay, out of these all, since this is a helium helium ion, and this is electron, this is neutral just like light, so heaviest out of all, definitely I hope you must have understood, alpha is the most heaviest and gamma is the most lightest. Okay, now what is ionization power? Ionization power is the ability of any atom, not atom exactly, any radiation to charge the air particles, like because these radiations would be traveling in space or environment, and we know in environment we do have air particles. So out of these, which can charge the air particles easily? So remember, charged one can easily charge something else. Like out of all these are mostly charged, most charged this particular thing is carrying. So this will have the highest ability to charge or ionize the other particles from where it is going to pass. So first would be this one, then second is electron, and gamma being neutral, it won't be able to ionize or convert something into charge because it itself is neutral. Next is penetration power, means how deep these radiations can travel or how easily it can pass from any object. So gamma being the most you can say damaging and most powerful out of all, so gamma can easily go through any kind of medium compared to beta and alpha. See, because you can easily remember that. Why? Because helium being the most heaviest will take difficulty in traveling to a longer distance. So longer distance, and also it can be easily stopped by maybe a metal, something like that. So here I hope this is fine. And next is the speed. Of course, gamma is actually actually travels with the speed of light. So the fastest would be the gamma because it is being the lightest, and alpha being the slowest. So gamma, beta and alpha. Mass, I think that is easily clear because heaviest, or they say mass, both are same exactly. Damaging to humans, so alpha order should be not this one, it should be gamma is the most damaging, followed by beta, followed by alpha. Gamma is also actually used for the treatment of cancer. So you can imagine they can kill the cancerous cell, and of course if they are used for killing cancerous cells, means these radiation can pass through our body easily. So from here you can remember they have got the highest penetration power and most damaging, right? Remember this sequence, and part 2 of this video I'll continue in the next one, because there we would be dealing with these radiations in detail. I mean, like how nucleus is affected when this alpha, beta, gamma they are being emitted, and from there definitely one question comes in your exam for sure, usually for 2 or 3 marks, like what will happen to the mass number and atomic number of an element if it emits alpha ray or beta or gamma and so on, right? So we'll continue in the next video. Thank you for watching.